like complete. And it's a pretty short quiz. It's 8 questions, and some of them are very simple yes or no questions. So it's worth it.
Okay. We're gonna go ahead and get started. So I'm going to be covering section C405, which deals with the electrical and power lighting systems. I like to basically break this section up and reorganize it so that it's more applicable to the standard design process. Also know that I don't have enough time to go through all of the changes of 2024. So I'll just be going over the major ones. But before I do that, their document, guys. And stop that hole. Okay. So there's a document that theoretically is being.
Do you guys need anything else from me before I take off?
That is being uploaded to the chat. So that is a PDF document for the entire section of C405 minus a handful of tables. That basically shows the changes 2018 to 21 to 24, what's staying the same, what has changed. I would encourage you to use that document in Acrobat, Bluebeam, however you're viewing your PDFs, to basically go through, highlight, comment what you don't like, what's concerning, what would be difficult for you to comply with, things like that, so that you can bring them to the Code Collaborative, DOPL, and the state legislature. But speaking of that, so through my rough analysis, there's about 32.71% of the 2018 code for lighting that is not changed. And then 2021 amended or changed 31.88%, and 24 amended or changed 35.41%. So quite a bit of changes going from both versions. There's some new sections. Some of them, like I said, I will go over them, but until the state legislature decides what version of 2024 we're going to get, it's kind of hard to make a training around all that, but it's something you should be aware of because you're able to participate in the conversation right now to govern what Idaho energy codes will be. So here are some of the sections. Lighting controls was renamed. We added horticulture lighting, and something that I am still trying to figure out who's responsible for is adding energy monitoring and renewable energy systems to the lighting section. It's a very big expansion of the lighting section. I'm not sure why it got classified under there, other than we had elevators, escalators, and some other motors and whatnot stuffed in the back of the lighting section, and so I guess we're just adding on to that. But like I said, I don't like to go through the code chronologically speaking. We're compliant with it. So where do you start is you have to decide, are you looking at the interior or the exterior? Basically decide which path. That's kind of how the lighting section is broken up. Either doing interior compliance or exterior compliance. Next, you have to decide what is your building type. And it could be speculative, it could be a shell or core, and it could be no. Okay. And something else to know that's changing is under here, dwelling units must comply with R404-1. So dwelling units and sleeping units for 2024 get pulled out of every section and they get put into their own section now. Okay, so it's a lot easier to understand. Rather than you won't have to be flipping back and forth between multiple sections as often, which is nice. Then you want to look at the floor area or the building area. So the total area or the estimated total area of building. And then your space and room schedule. How is the building going to be used? Estimate the space types. So for an example, I'm going to walk through. We're going to do interior. We're going to look at a high school. We're going to say it's 137,600 square feet. The reason for that is I'm pulling from CBEX, the Commercial Building Energy Consumption Survey, 2018 data set, looking at climate zones 1, 2, which is the climate zones for Idaho, as Damon mentioned, ASHRAE 5B, 6B. CBEX has its own climate zones, but they're closely linked to ASHRAE's climate zones. And so then looking at what programs we're going to need, classroom, gymnasium, administration. And so when you're getting an idea of that, you want to know, what is our allowance, right? How much are we allowed to spend for our lighting system for our building? So first I'm going to talk about the building area method. So like I said, we're going to do a high school. For the one thing to note for the building area method is you can have multiple applicable area methods is an area shall be defined as all contiguous spaces that accommodate or associate with a single building area type. Contiguous means they're touching. And so what we're going to do here is we're going to look for our total interior lighting power by looking at our building area with the lighting power density requirement provided by code. So here's kind of a walkthrough of how to get to that equation. So basically, yeah, so we're interior lighting power or watts, equal to area times lighting power density. So using the 2018 example or 2018 reference is 0.81 LPD. Yes. But for 2024, that's going to be dropped. Yeah. Okay. But for 2024, that is 0.7 lighting power density. So if we take our area times the lighting power density, that's going to give us 96,320 watts for 2024. But under the 2018 code, that would be 111,456 watts. So that's our allowance. That's what we have to spend for all our building spaces. Doesn't mean you have to spend all of it. The other method is the space by space method. Basically, allowance is determined by multiplying the floor area of each space times the value of the space provided. So now, instead of a building LPD, we're going to have a space LPD, and then summing all those lighting power allowances for the space to give us our total allowance. Something to note with the space by space method for the unfinished spaces, your core and shell, so to speak, there is a change to the watts per square foot. So you're going to get 0.1 watts per square foot now. And then sleeping and dwelling units are not included in the calculation for either method. So keep that in mind. They have their own section now for 2024. And so estimated building program. So like I said, would be ideal if you start this in the pre-design to the design process, figuring out what your allowance is, how you're going to be spending. Because while you're doing that, this is what you're doing. You're figuring out your program, how it relates to each other, how many you need, the space requirements, standards from the state, etc. And then as you go through the design process, it gets a little more refined. And so you can basically kind of go through there and estimate what your allowance could be. And then you can just update that as you move through the design process to see if you're still in compliance. So with the space by space method, here's the changes from 2018 to 2024. If I remember correctly, there's only two values that did not change. One of them is here, is the copy print room. So here for the common space types, I just went through and just applied all the applicable programming for our fictional high school that we are designing, and the applicable LBD that's going to be applied for that space type. And then there's some pretty specific areas. So if you have, a general space by space type versus a specific space by space type, you're required to use the more specific one than the general one. If it's not on the list, then you have to choose the next closest applicable space type. This list, the LPD for building area method and space by space get updated every code cycle. In 2020, all of this would be basically blue. That's because we're jumping 2 versions, so everything was pretty much updated at one point. Whether even not, it went back to its original value, like for the copy print room. So it changes. Some get added, some get subtracted with each code cycle. So just keep that in mind. They, like I mentioned, they're separated into common versus specific. Specific space type shall apply. You get stuck between 2. So here's an example. I recommend just building this in Excel. There's another program I can show you in a moment. But basically have it in Excel. What's the LPD based on the space type? More specific programming if necessary. And then what's the number? So this, I kind of tried to follow the Wyoming, Montana, and Idaho state guidelines for school requirements and whatnot. So that's kind of how we got the area here. And so then using that same equation from earlier, we'll get our watts allowed or interior lighting power. And so with the space by space method, we get 85,374.64 watts to spend. I'll go into more of the math in a little bit. But comparing the two, the building area method is a quick and easy. However, there's no exceptions, so you get what you get. That's your allotted allowance, and if you don't budget correctly, kind of SOL. Space by space method is more granular. It ensures that you will have a sufficient allowance. Part of that is through exceptions and trade-offs of the allowance going from one space to another. You can only do that with the space by space method. I'll typically see the space by space method utilized for, as Dr. Woods was mentioning earlier, energy performance modeling, basically proving that, one part of your system is more efficient, so you can trade that off and have a less efficient glazing system, so you get a lot more windows, things like that. So the building area method is ideal for standard and predictable programs. Offices or shopping centers, could be schools, but I would say that's more for elementary or middle school. Once you get to high school, building area increases, the specialty classrooms and curriculum changes. There's also just a lot more students. For the space by space method, it's not for non-standard buildings or building types. So think museums, theaters, casinos. Programs that are just, are going to have a higher kilowatt share for the lighting system, especially if they're decorative, accent, or application specific. So with our building area method, we got 96,320 watts for our allowance. In 2018, that would be 111,456 watts. The difference between the two is 15,136 watts. So that's how much less power we have to spend for our building spaces going from 2018 to 24. Same thing holds true for the space by space method. We're losing 18,673.62 watts that we can spend. And so variables to consider, because you get to decide which path is best suitable for your project. Square footage, program requirements, and kind of the information drip associated with those. How long do you think it's going to take for you to get that information to be refined and nailed down? An example would be, a retail department store starts with the building area method, but as the program, just kind of give you a starting point, kind of an idea of what you're going to be spending watt wise. But then you realize as the program becomes more defined, you would benefit from the space by space method because of clothing, jewelry, or sporting goods sections within the department store. With a grocery store, same thing, if it's food only, building area method. If it's food and retail, you're probably going to need some additional lighting power or being needing to trade between spaces. As I mentioned earlier, schools, elementary, middle, building area method is more applicable. You do high school or K through 12, then you want some more flexibility and granular trading of your wattage for high school or K through 12. So what does that mean as far as the energy codes? They're, as Dr. Woods mentioned, they're the baseline minimum, right? You have to do this, it's the minimum requirement. But they're also intended to kind of save operational costs, right? Kind of raise the tide, so to speak, of the savings that we can achieve. So calculating operational hours for schools in Idaho is a little bit tricky. The state legislature is currently fighting with a lot of school districts because some of them want to go to 4 days a week versus 5 days a week. 5 days a week is, I think, 171, 172 days. So I just went with the minimum that the state legislature, I believe, passed, not this past cycle, but the one before it. So Idaho, you have to have a minimum of 152 instructional days per year. If we say 10-hour working days, then we're going to get 1,520 hours per year, times that by our wattage after we convert our watts to kilowatts. So for 2018, that would be 169,000 roughly. For 2024, that's 146,000. So we would have an operational savings of roughly 23,000 kilowatt hours per year just by reducing the load of our lighting system through more stringent requirements. The space method is very similar, but you actually end up saving more watts, roughly 28,000 or 29,000, sorry, kilowatt hours per year. The reason for that is because we just have less to spend, but it's much more flexible. So other options. So if you don't have a working room schedule in Revit or Excel, I would encourage you to check out Contract Web. So you can basically just kind of put in averages, basic information to kind of get the project started, and then you can start putting in your space types, the area, and you can tell it which code you're needing to be in compliance with, and it will basically help you. It will tell you, you know, like, I want to add this fixture. It's a 2x4 troffer, 28 watts. I got, 75 of them in my building. These are the space types or the building area method. You actually choose, are you doing the building area method or are you doing the space by space? And so it can kind of basically help you walk through it and figure out, are you in compliance before you go start spending, basically. And then you can just update those values or copy the project and then, do 002 version. And be like, these are the updated values. We talked to the electrician, we talked to the lighting manager, salesman, and this is the new products that are going in and the quantity of those. So I've been talking about allowance a lot. So real quick, allowance versus budget. Allowance is a specific amount of money included in your budget, which is allocated to be spent on specific item or service. Okay. And just real quick, here's the lumen output for luminous efficacy that we measure for lights. So now that we have our lighting allowance, we need to make our lighting budget, right? How much are we actually going to spend and where is it going to go? And so you're a lighting designer, electrical engineer. Basically, you're going to take your lighting matrix that you're making and you're going to just incorporate some additional values for code. And if you've heard me lecture before on energy modeling, I talk about the floor and the ceiling. Code minimum being the floor, and then high performance being the ceiling, and we want to kind of fall somewhere in between those. And that kind of helps you navigate the energy modeling or any kind of process that deals with a significant amount of data. So again, we're looking at a high school, so standard classroom. Here are the requirements because it's traditional high school. I'm going Jurassic Park, so each one is 1,240 square feet. We're sparing no expense. Okay. And so in red, 0.96, that's the LPD requirements. And then 0.72 is the requirement for 2024. So quite a significant reduction from 2018 to 24. And so what we're doing here is we're just doing a basic layout. So here, the layout doesn't have to be 27.5 feet by 45 feet. It could be however you would like to arrange that. I just did this so I could establish a grid with my 2x4 recessed choppers. And so now we're looking at, I use 35 watts, which is an average for LED fixtures. You could probably get away with 28, 30 watts as your average, but I want to be conservative with my estimates because it's easier to pull back than it is to climb up. And so here we're looking at, what's the grid layout? We go 10 fixtures, 15, 20, 25, 34. And so this last line is what I made for 2018 to establish the ceiling. As in we cannot go above that, right? So in this layout, this 1,240 square foot classroom, I'm not allowed to have more than 34 fixtures at 35 watts. Obviously, we wouldn't need 35 fixtures for our classroom of that size. But so basically, we get an idea of how many fixtures we will need. So say we were very conservative and we have 10 fixtures, then we have a 0.28 LPD and we're coming significantly under. And because this is the space by space method, that's a lot of wattage that we can now trade to say our gymnasium, our theater, our library, our computer room, etc. And so trying to figure out, so now with 2024 being 0.72, the new maximum I can put in is 25 fixtures at 35 watts, okay? And so a little more of a realistic example, 850 square foot for our classroom. So seeing how that changes. And so with this size, keeping with 35 watts per fixture, we could get away with a maximum of 17 fixtures to come under 0.72 and be in compliance. And so what that tells me is that, okay, 17 is the max. I should probably try for 10, see if I can get a grid layout for uniform illumination of 35 or 50 foot candles. But if I have to add, say 2, so I have 12, I have a 3x4 grid in the classroom, that's perfectly fine because I'm going to come in between 0.41 and 0.6. So I know that that design decision is acceptable down the line. Okay. So looking at our lighting budget, if we take our 96,320 watts allowed to us by the building area method, and say we take 15 fixtures for our classrooms at 35 watts, that gives us 525 watts per classroom. At 59 classrooms, that gives us 30,975 watts. So 32.15% of our budget is being allocated to classroom lighting. And so I like to kind of put it as a percentage with all the space types so you can see, okay, 32.15, that's probably going to be pretty significant of our building area. So if we focus our attention and our resources there, we're going to get a greater rate of return for our time. The space by space method, using the 850 classroom, we're going to get 612 watts permitted. 59 classrooms at 612 watts, we're going to get 36,108 watts that we're allowed to spend. But based off of how many actual watts we're going to be using in our classroom with the 15 fixtures at 35 watts, so subtract that, we're going to get 5,103 tradable watts that we can just trade between our spaces. Okay. Anyone confused on that? So, okay. So if you don't want to do at the building level, say you're just going through the design process and you want to make sure that this is going to be kosher down the line. So doing that same thing, but just with a single classroom. So 15 fixtures at 35 watts, 525 watts per classroom. So we have 612 watts permitted per classroom. Subtract those two, we get 87 watts tradable per classroom. Okay, and so because you have enough watts to trade, that you're good. Okay, so if you have negative tradable watts, that's bad, and then you're in the hole. And just keep in mind, unless explicitly stated by code, a trade-off or exemption, it will tell you when you're allowed to do that. So it doesn't explicitly tell you you're not allowed to do it. Another example for the space by space method. So let's take a gymnasium or fitness center, and specifically the in-playing area. So we got a 0.23 LPD. Let's just say it's 2,500 square feet. Watts permitted is 575. That's area times LPD. And let's say we got our LED high bay fixtures, each one's at 85 watts. So we got 6 fixtures, it's 510 watts. So we got a 0.204 LVD, which is great. We're underneath the requirement for 2024. And so we have 65 tradable watts. And you don't really want to min-max your lighting power allowance because you basically think of it like a safety load, right? We design something structurally to hold up to a certain point, and then we apply a factor of safety so it goes above that. Same thing, you want that cushion room just in case anything happens in your design. Maybe you got a change order, you got to order a completely different fixture. You're really going to wish you had that budget room. So for determining your budget, do these projections for each space, regardless of the method being applied. It will save you work down the line. Have projections set up early in the early design and schematic design phase that will make construction, DD, compliance, ComCheck significantly easier. And then this workflow can basically be repeated. So once you have it set up once, you can just use it for the next project. You might have to change things if the building type, drastically shifts. But for the most part, you'll have an outline that you can use moving forward. Another thing I want to show you real quick, technology permits. So this is not a product endorsement. Okay, we do not endorse products at the IDL unless it's a design tool that we created. So this is a tool I found from my grad school days, and this is what I like to do for just rough, quick calculations going through just some simulations. And so you can basically just get an empty box and basically so you can load in. So this is the current luminaire. You can change as its IES file, and you can change from their library. So again, not a product endorsement that we kind of liked. But basically, then you can change the room size, length, width. You can mess with the reflectance, or sorry, you can change luminaire. You can go in and you can edit that. You can change projection factor, details about the luminaire, as well as its actual shape. So if you want to kind of jerry rig your own custom one that you're thinking about using, room size, reflectance, work plane height, ceiling, walls, floors. Specify what is your foot candle you're looking for versus calculated luminaires, power level density. So this is a great tool I've been using since grad school, but a lot of the lighting manufacturers have it. I just, out of habit, go back to this. Okay. So again, that one's from Econolight, but Enlight, Lithuania, they all got their own version of it. Whether or not it's free, I make no promises. So we have our allowance and our budget, and now the code official wants to audit us, right? They want to make sure we are spending correctly. So this is how you do that. This is the equation for total connected lighting power. This equation, I imagine in future versions, is going to get a lot more simple due to LED kind of being the major commercial lighting type now. There are entire sections of the lighting code rewritten, which I'll get into in the next lecture about that. But basically, you're taking all your connected luminaires and you're adding them up to figure out what is the total connected interior lighting power. The reason why we go through this is because there are exemptions, okay? So there are exemptions that you do not have to count towards your interior lighting power, okay? Now, keep in mind, just because the code official says you don't have to count that wattage, Idaho Power is still going to charge you the kilowatt hours it takes to operate that fixture, okay? So that's, again, why I like to calculate what are the total allowances in the budget and then figure out what is the actual power the code official is looking for. And so with the exemptions, don't try to color it, all right? It's black and white, pretty simple. It is as it comes through. So, makeup lighting, emergency lighting, casino, broadcasting, etc. It's pretty straightforward. Just make sure you have the area of where that's occurring locked down and that you know how much power is being used there, so you can basically show your work. Basically, this is our allowance, this is our budget, these are our exemptions, and then this is our additional lighting power, which I'll get to in a moment. But yeah, so they're pretty straightforward. Medical, museum, photography, basically any kind of building type or space function that requires a significant amount of lighting to do its job. We're not going to punish for that. Okay. Lighting for food warming, lighting equipment that is for sale, demonstrations, lighting approved as safety concerns, furniture mounted supplemental task lighting that is controlled by automatic shutoff. So you're going to see things like that in the lighting code, where whoever wrote the code somehow assumes that you as the designer have control of the space after it's built and occupied and signed it over. So take it with a grain of salt. One that was added for 2024 is number 20 for exit access and exit stairways. Code requires an illuminance of 10-foot candles or more on the walking surface. The power in excess of the allowed power calculated according to section C is not included. Okay, so there's a lot of for safety concerns. You're not going to be docked. Okay, you just have to make sure it's in the right place and that is justifiable. So calculate total interior lighting power first, then apply exemptions and trade-offs. Show your work. Okay, it's going to help you keep track of it, as well as anyone else on the project who needs to take a look at it. And the code official inspector will thank you for it. And last, don't forget parking. Okay, I'm kind of butting heads with people at IECC because their definition of interior parking doesn't work. Mine, basically, interior parking should be treated like the interior, because again, lighting is broken into interior and exterior. It's very clearly defined, either one or the other. With interior parking, it's kind of a hybrid. So in my opinion, if it's not being air conditioned, it's exterior, right? Just sole fact, just to make it easier. But the powers that be disagree. Okay, so just keep that in mind, that if it's covered or enclosed, including open parking garages, are included in the requirements for interior lighting. Okay, I don't agree with it. I don't like it, but I got to do it. Okay. For those of you curious about the lamps in the equation, here they are. And so SSL, solid state lighting, or as we commonly refer to it as LED, is becoming the main driver lighting type in the commercial building sector. You can see that clearly by its gains in the commercial building energy consumption survey. So let's calculate our interior lighting power. Again, you can use ComCheck online to kind of help you walk you through the space, especially if you're like, say, hey, my electronics section is 800 square feet. What happens if I make it 1,400 square feet? What does that do to my power allocation, right? For those of you not familiar with this is a Costco. Okay. So we're gonna kind of use a Costco retail area layout as kind of the example for our additional interior lighting power, right? Because that's retail is what we get, because we're selling things and people like what they sell to be shiny and bright and attract you and want you to purchase it. So these additional power allowances shall be used for luminaires serving the specific lighting function. This is a change from 2018 to 24. I'm guessing a lot of people were getting a little laxed with their additional interior lighting power justification, so we're kind of drilling it down. But the equations stayed the same. So additional interior lighting power allowance, you get 1,000 watts plus different retail categories. The area times the wattage, sum all those up. That's going to be what you're allowed to spend specifically for those lighting functions. Okay. Additionally, some additional language added was power allowance shall be connected lighting power of the luminaire, specifically highlighting merchandise calculated in accordance with equation 4.9 or the additional power allowance equation 4.10, whichever is less. Okay, so you don't get to get extra money or watts to spend. Okay, so here are the categories. Retail category 1 is anything that doesn't fit into 3 or 4. Retail 2 is the sale of vehicles, sporting goods, or small electronics. Retail 3 is furniture, clothing, cosmetic, and artworks. Retail 4 is jewelry, crystals, and china. Okay, so if you don't fit in 2, 3, or 4, then you fit in 1. So if we take those rough areas that I got online from that Costco, and we plug them into our equation, we would get an additional 44,740 watts specifically for those applications. Okay, you know, just go start spending them elsewhere, wherever you want. The additional lighting power shall be the smallest of the following. Or sorry, choose the expanded section. So there's an additional requirement. So lighting, for which lighting is specified to be installed in addition to the general lighting for purposes of decorative appearance or for highlighting arts or exhibits, you'll get additional lighting power, but it's going to be the smaller of the two based on these 3 categories. There's another equation there. Okay, so again, this is why I recommend Excel, because you could just have these default equations in there and then just change the cell with the new variable that you're looking at. Again, cannot stress this enough. This is just based on my reading of the changes of code. The additional power shall not be used for any other purposes. Okay, do not abuse it. I think we're upsetting the code officials a little bit. It has to be installed and automatically controlled separately from the general lighting to be turned off during non-business hours. Again, some of the code officials think that we have this enormous power to dictate how occupants and tenants use the space. So this is how it should be set up. Whether or not it remains that way in operation is a different story. And again, this is why you would consider the space by space method, is because you'll get additional interior lighting power. So horticultural lighting, I really don't like this section, mostly because I don't want to have to teach people about UMOLs. I learned that in chemistry. I thought I was done with it, except when I work on greenhouses. Not the case. I'm not going to go into depth on this because Idaho is an agricultural powerhouse state. Try applying code to any agricultural building. Let me know how it goes. Okay. So I wouldn't worry about this section too much. And again, one of the grounds I disagree with this section on is for horticultural lighting, the crop, the plants that you're harvesting or generating, part of the operating cost is the lighting. So you are incentivized as a building operator, business owner, operator, to reduce your operating costs. So we shouldn't be telling you how much energy you're spending growing, as well as what the frequency or intensity of those light waves should be. The plant that you are cultivating will tell you that. Okay. So now we're gonna run through exterior lighting power allowance. This is a little bit different. So there's different zones that are applicable to your site. You want to pick which one is most applicable. If you can't choose a zone that your site fits into, ask the code official, have them make a ruling on it. Okay. What is the program of each zone? So these zones have not changed from 2018 to 21 or 24. So you got developed areas, national parks, state parks, forest lands, rural areas. 2 is areas predominantly consisting of residential zoning, neighborhood, business districts, light industrial with limited nighttime use, residential mixed use areas. 3 is all the areas not classified in 1, 2, or 4. So if you don't fit in 1, 2, or 4, then you go to 3. So it's pretty hard to kind of, say, you kind of have to be on the border of like, oh man, I think I'm for, a high commercial activity district, but maybe you're not. So then you would ask the code official to make a ruling, am I going to 3? Am I going to 4? So yeah, so unless otherwise specified by code official, that's literally in the code, okay? So here are some changes. Take this table with a grain of salt. I think there's an error on the 2024 code that's missing a couple rows. I didn't see represented. That should be there because the commentary and everything around it acts like it is there, but it's not represented. But so basically in red is 2018, and then in black is the 2024 change. So there's some name changes. The one I say take with a grain of salt is building grounds, walkways and ramps less than 10 feet wide. This got the walkways and ramps 10 feet wide or greater is not shown. And then the less than 10 feet wide for walkways is kind of cut off in the online code version of it. So I'll get that updated hopefully soon. But here are those values. And so one addition that happened was plaza areas. So that's completely new. So there's no distinction between before or after. But you can see basically kind of a reduction across the board for the amount of light you're allowed in your exterior lighting power. Basically LEDs, they're still at it. They're still adjusting and impacting our code and how we're calibrating those. And then there's two. Yeah, so quite a bit got added and changed to this. So I would definitely encourage you to review it. A lot of it is going down. There's kind of a reduction across the board. I don't think there's any place that got more other than the pedestrian and vehicular exits or entrances and exits. And in my opinion, I think that kind of has to do with the fact that we're applying controls now to interior parking garages. So we want to make sure we have enough light for safety, for driving, being able to see, etc. The other thing is uncovered entrances and gatehouse inspection stations at guarded facilities. That got reworded and the values changed. ATM and night deposits, again, that got a significant reduction. So basically zone 1, I apologize if you're working in zone 1, you're going to have a very difficult time, but for good reason. I am a conservationist. I do like outdoors, open spaces, etc. So we should try to preserve those as much as possible. But basically you're probably going to be working in zone 3 quite a bit, unless you're residential or you're commercial or urban, heavily urban, zone 4. So quite a bit of changes. Again, if you have this in an Excel sheet, you're just updating the values. It simplifies the work a lot. Or if you don't want to build out your own Excel sheet, use OnCheck Online. It's free. You just need an account. Drive up windows and doors got changed. Parking near 24-hour retail entrances also got changed. So like I said, with a lot of the tables, they're just getting updated in response to CVEX, market dynamics, what manufacturers are doing. There are exceptions for determining. So lighting approved because of safety concerns. Again, just make sure you have a narrative. You can justify that. Kind of go through the control system. Like if someone walks, here at the occupancy sensor where you're telling me to have it installed, it's not going to trigger them until they're X amount distance where they should be. Things like that. Emergency lighting automatically off during normal business operations, exit signs, specialized signage, direction marker, lighting for transportation, advertising, etc. Integral to equipment or instrumentation and installed by its manufacturer. So again, not going to ask you to kind of take something apart. One thing that did change is no longer theatrical purposes, including performance, stage, film production, and video production. Instead, it's been reworked to say lighting in any location that is specifically used for video broadcasting, video, film recording, or live theatrical and music performances. Athletic playing areas, temporary lighting, theme lighting, amusement parks, anything you use to highlight or accent a certain part of monuments, flags, artworks, aesthetics, things like that. Again, lighting for sleeping units and dwelling units, they're getting their own section, so you don't have to go constantly back to the residential one anymore. Lighting of the exterior means of egress as required by the International Building Code. So energy code is kind of punting that one and saying, hey, just do what they do. It's good enough. Okay. Additional sections that were added. Data center and computer rooms. This is just power and electrical requirements. I'm not going to go over that. There's nothing in regards to the lighting other than the controls, which I'll get into in the next lecture. 10 and 11 had no changes, but they were just renamed due to additional sections being added before and after. And then we have automatic receptacle control. This was added in 21 with no changes to 24. I don't believe this was recommended by DOPL to be accepted. Yeah, so don't have to worry about that. One of the reasons why I'm against automatic receptacle control is we have Energy Star, we have low power mode, sleep mode, things like that that function. So this really, in my opinion, it's very building type specific, and then even further, it's occupant type specific, so don't worry too much about that one. So energy monitoring. So 405.3, this is a new section that got added in 21. It was updated in 24, so that not less than 10,000 square feet shall be put to measure, monitor, record, and report energy consumption in accordance with the section for the appropriate load categories listed in that table. And then there's a bunch of end use categories. I'm going to go through all that, don't worry. But basically, so this was added in 21, and then what changed was the square footage requirement. Exceptions, dwelling units, and R2 occupancies, and then individual tenant spaces are not required to comply with the section, provided that the space has its own utility service and meters and has less than 5,000 square feet of conditioned floor area. Okay, so basically it's saying you don't have to include that because it's already monitoring itself. So basically, as it sounds, some of this is just because it's new, it's like, hey, we got to define this and put it in the code. So meter approved devices must collect energy use data for all electrical energy supplied to the building and site. These are the categories that were interested for electric metering, HVAC, interior lighting, exterior lighting, plug loads, process loads, miscellaneous building operations, and electric hot water. Again, exceptions, individual dwelling units, and certain small tenant spaces. The meters must automatically communicate data to data acquisition systems, hourly data capability required. You can do non-intrusive load monitoring in an ILM. So again, all these sections we're going over right now, completely brand new. I'm just summarizing them because I don't know what's going to be adopted by the state legislature, what's going to be amended, what's going to be restricted. Maybe something becomes optional instead of mandatory, things like that. So take it with a grain of salt.
Yeah, I'll just note that the current proposal before the legislature is to not have any of this section, any of the energy monitoring devices in commercial buildings would not be required. So the legislature probably won't get into the details of like any individual section. They will either say, we take these amendments as they are or not. So let's see.
But a lot of this, you can see similarities to HVAC and BACnet. We're basically trying to start requiring that for lighting. I am pro this because I am pro smart lighting, luminous lighting controls. And so having this will just further extend that reach and interoperability of smart lighting to kind of extend other building control systems and functionality for occupant comfort and efficiency. But just as kind of an idea overview of what you're going to be, what's in there. If you have a client that wants to take a look at it or is interested in doing something like that, I'd recommend just, even though it's not going to be required, it's just a good guideline to have. Some of it I disagree with. For example, having a graphical energy report requirement. This is on the software manufacturer to do. So they have to, basically, you have to go and find a software that complies with this and hope that you can, or that the manufacturer built their software to be compatible with the requirements of our energy or graphical energy reports. So there's some of it I disagree with. Like obviously we do need to have a way to view the data. Visually is better, especially for people that don't necessarily do energy modeling. But I feel it'd be better to have the market compete and decide what are the best features, what is the best interface, things like that to decide. Renewable energy, again, this is also not making it in there, but it is being considered for the code cycle that where they would like to start requiring you to do some type of renewable energy and monitoring that. And then non-electrical submetering, so gas, district heating, etc. Exceptions similar, it's basically similar to electrical metering, but just for a different fuel source. Again, non-electrical submetering, so graphic reporting, etc. Like I said, they really just stuck this in at the end, and it's like it goes here now. So, renewable energy system. So if you go through the code, and you see sections like this where you see C405.14 is reserved. Below that, you're probably going to see something that says, you know, title and then control function. So basically, what this sets up is like a guideline for this is how we would like you to control this, and then the one that's reserved is kind of a hint saying, hey, next cycle we're going to put something in that says it's required and it's required for these buildings or these space types or etc. And then this is how we want you to control it. And that's all I got for this lecture. The next one I'm going to be going over is the control strategies and requirements lighting. So if you have any questions, I'll take those.
Joey's lost the poll.
Yes, please. Also, for in person, there's food over there, so please help yourself.
Would have access to these slides.
You can.
Yeah.
So
There's some good
Email
information
you.
there.
Yeah.
You went about really, really fast.
sorry, there's a lot to go over, but
No, I get it.
you have.
Thank you.
Yeah.
And thanks much. Peace.
Next one starting in 10 minutes.
Yes.
Any questions from class as well? Yeah,
I'm just curious, so when I was looking at the exterior costs, I saw the reduction of, what was it for? I don't remember what it was called, the reduction in the wattage, was that the allowance? And when you say allowance, is that going over or under the required amount?
Yeah, so Dylan, you wanna,
No, you're the professor.
not the lighting expert,
I know.
not the expert in everything.
Sorry, what was the question again?
Yeah, so the side for the electrical costs or exterior costs, there was a reduction on the wattage it looked like. And it's was saying it was reduction in the allowance. Was that the ones right above it? Yeah.
Yeah.
So is that going from 2018 to 2024?
Yeah, so it's kind of confusing because I'm trying to show both.
Yeah.
But technically this training is on 2018.
Okay, yeah.
So basically like zone 1, you're going from 300, if your building has to comply with 2018, you get 350 watts for if your site is designated as zone 1.
Gotcha.
And as far as how you're spending those, so this is like your allowance, and then we got our line items, and this is our budget. This is where our allowance is going, how we're budgeting that amount. Does that make sense?
Mhm.
And so for zone 1, you're going from 350 watts to 160 if you have to comply with 2024.
So you still have to provide lumens, you're just now forced to do it using fewer watts.
So you have to be more strategic about where you place your lights, as well as just the type of light you select. As well as just also kind of basically forces your hand and be like, use LEDs. only LEDs. LEDs is
Yeah.
kind of what it's going for, because it wants you to use more efficient fixtures rather than so rather than halogen or high intensity discharge, just other types of lighting that are very well effective, just not as energy efficient that we would like. And so the code is just trying to raise all tides so that everything's just more efficient. And so that kind of reduces your options that you can use to select fixtures. So, like I don't think it's illegal anymore for using incandescent bulb. This is some executive orders that were recently signed. But it's trying to basically like this technology, while it works, it should no longer be applicable. There are much better options out it. This is the new best workflow, so to speak.
Gotcha. So the incandescent were using full wattage originally as opposed to that.
Yeah, and also just like heat, you gotta deal with that. So if you had a building, it's using 2x4 P8s, T12s, right, and it has 3 bulbs or 4 bulbs, and you multiply that, that one fixture by 400. Now you kind of got a heat load that you have to deal with. And so one things we found is if you say retrofit that building, right, you replace all 400 fixtures with LEDs. Now you have to rebalance your HVAC system because your heating load is now different. So measuring those impacts. Same thing if for a snow load on a roof, if you have a very high insulated value on the roof, you better make sure your snow load calcs are really in line because that snow's not melting away from excess heat escaping the building. So
we did have some schools in Idaho that had their roofs collapse when they
yeah
added extra insulation. Yeah, so not an issue for new buildings, right? But for older buildings, sometimes there's consequences. Actually, in the reading for classes still here, hopefully you read the final chapter of the book, and it was just like 2 pages, but it was that as we get to these high performance buildings, the margin between doing something stupid and having a really bad effect, or between stupid and hurt, is getting smaller, right? As we kind of hyper insulate our buildings and change our ventilation systems and add more controls. If you screw up, there's basically less margin for error now, and that's kind of what we saw with some of the roof collapses and things like that. Hopefully our buildings are getting better, but you can't just be sloppy about it as performance goes up.
I'm gonna go to the restroom real quick.
All right.